Great warm-up. So we're looking for the point slope form of a line. The point slope form of a line, remember, is y minus y sub 1 equals m times the quantity x minus x sub 1. And for it, I need a point and I need a slope. Okay? I am given 2 points in the problem. So we've got that taken care of. Okay? But we need to find the slope. So the slope between any 2 points is we subtract the y's over we subtract the x's, which would be 7 minus negative 5 all over negative 2 minus 3. 7 minus negative 5, negative 2 minus 3. Love it. 7 minus negative 5 is positive 12. Negative 2 minus negative 3 is negative 5. Okay, so that is my slope. So the point slope form of this line could be y minus 7 equals negative 12 fifths times the quantity x minus negative 2. I'm going to write it as x plus 2. Okay. That's if I use the point negative 2 comma 7. Or y plus 5, so y minus negative 5 equals negative 12 fifths times x minus 3, if I use 3 comma negative 5. Either one of those would work. You would not have to give both of them, and you'd have to give one of them. We would be responsible for the other one, or for both of them on our answer key if we needed it to be done. Okay? Questions, comments, concerns, clarifications? Love it. So now we are in so we talked about that already today. We're going to do the projectile motion page from P7, which is that third page there on that packet from yesterday. That or a bunch of people who actually blame me. So a projectile launched vertically can be modeled with the equation S equals negative 16t squared plus v sub 0t plus s sub 0, where s is the height of the object, v sub 0 is the initial velocity, t is time, and s sub 0 is the initial time. So, a projectile is launched straight up, because this is the straight up part. When we launch things at an angle, that will be in equal. Okay? We're going to launch things at an angle. That's the fun part of the trick. Okay? Projectiles launch straight up from ground level with an initial velocity of 272 feet per second. Okay? Write an equation that models this situation. Okay? What do we think the equation is going to be? I'll start us out. S equals. What's the rest of the equation? Yeah.
S equals negative 16t to the second.
Okay, negative 16t squared.
Plus 272g.
Okay.
And since you're starting from
0. So plus 0 really there, so we don't have to write. Do we all agree with that? Yep, I would agree with that as our equation that models the situation. The next question is, when will the height of the object be 960 feet above the ground? There are two ways that we can do this. The first way is we could do it algebraically. We have the equation for the height of our object, which is what we just figured out. It is s equals negative 16t squared plus 272t. Okay? So what would we do to find out when that height is 960 feet off the ground? Set it equal to 960. Now what? Subtract 960. Okay. So I got more space. So then we get it equal to 0 is what you're saying? Yes. Okay. Ooh, somebody with a calculator does 16 go into 262. The 16 go into 960. Because if so, we can factor out 16. It does? Okay. So let's factor out a negative 16 then. (262) divided by 16? 17. So it'd be minus 17 because we're factoring out a negative 16. 960 divided by 16? 60. But it would be plus 60. Okay. Is that factored? Are there two numbers that multiply together to be positive 60 and add to the negative 17? Whatever. 12 and 5, but would be minus 12 and minus 5, right? Okay. Which then that's going to mean that, correct? So what does that mean?
After 5 seconds, it should be shown 16. After 12 seconds, it should be shown 16.
So at 12 seconds and at 5 seconds and at 12 seconds, it's at 960 feet. Okay. Two more questions, and they're actually pretty easy. Okay? Next question is, when will the height of the object be at least 960 feet? So what is that object doing? We launch it. 5 seconds later, it's at 960 feet. Then what happens to it? Keeps going up, right? Stops. Gravity takes hold, stops. And then it comes back down. At 12 seconds, it's back to 960 feet. And then at 17 seconds, it's back at the ground. Right? Okay? So, when will it be at least 960 feet? Inclusive or exclusive? Because it's at least, right? When will the height of the object be at most 960 feet? 0 to 5 exclusive or inclusive? In what? You're thinking inclusive at 5? Why are we thinking inclusive at 5? At most. And just like we said at least before. Right? So I would go inclusive there too. And what's the other one? 12, right? 12 to 0? No. It's got to be bigger than 12, right?
Yeah.
Why 17?
After 17 seconds is when it'll hit the ground.
How do you know it's 17 seconds to hit the ground?
I'm assuming because 960 feet takes 5 seconds, so then 12, yeah.
So it took 5 to get up there, right?
Yeah.
It's going to take 5 to get back down. Exactly. But that factors in. Because that initial velocity factors in. So it's already going at that. So that's why the initial velocity gets the height coming back down. It will be going when it hits the ground. How fast will our object be moving when it hits the ground at 17 seconds?
Well,
How fast? 272 meters per second.